Hello. So today we are going to be going through section 9.3, which is evaluating trig functions of any angles. So today we're going to do examples 1 and 2, and tomorrow we'll finish up with examples 3 and 4. So this should look familiar. You're starting with your coordinate plane. You have your circle. The equation that goes with it is x squared plus y squared equals r squared, which should sort of remind you of Pythagorean theorem. So where it all comes into play is it's saying if there's an angle, which we call theta always, anytime you have an angle that you don't know the measurement of, you call it theta. And the point on the outside of the circle is x comma y. What's new today is that your radius r is going to be in the circle. So you're still going to go back and find your 6 trig functions just like we did in 9.1, but now you're going to use this new information. So I did post this chart in your Google Classroom as sort of your reference sheet. If you have a printer, it'll be good to print it out, but you'll use this a lot today. So the sine is going to be y over r. Your cosine is x over r. Your tangent is y over x, where x cannot equal 0, because when x equals 0, that would be undefined. Your cosecant is just the opposite of your sine, so r over y. Your secant is the opposite of cosine, so r over x. Both of these cannot be equal to 0 in the denominator. And then your cotangent is x over y, where y cannot be equal to 0. So the only two that don't have that little stipulation are these first two, because r is never going to be 0. R is a unit of measurement, and a unit of measurement can never be, obviously, 0, because that wouldn't be anything. So that's sort of your reference that we're going to go through and use for all of these problems. So the first one says, evaluate a trig function given a point. Let -4, 3 be a point on the terminal side of the angle, theta, in standard position. Evaluate the 6 trig functions of theta. So basically, you're saying you need -4, 3, which is somewhere in this general direction. So therefore, that is your angle. So -4, 3. And in order to do all of these things, you need y, you need r, and you need x. So we have x, we have y, we need to find r. So we're going to sort of use a variation of this formula. So r equals the square root of x squared plus y squared. So again, should remind you of Pythagorean theorem. So x being -4, y being 3. So r equals the square root of -4. Remember to put something in parentheses if it's negative. Plus 3 squared equals square root of 16 plus 9, which is square root of 25. So r equals 5. So again, r equals 5, x equals -4, y equals 3. And then we're just going to do these top 6 functions. So the sine of theta is equal to y over r, which is 3 over 5. The cosine of theta is x over r, which is -4 over 5. The tangent of theta is y over x, which is 3 over -4. So they should look familiar to the ones that were given to us in 9.1. Regular fractions, nothing too crazy. Cosecant is just the opposite, so it'd be 5 over 3. It'd be r over y. Secant of theta is going to be r over x, or the opposite, 5 over -4. Doesn't matter if the negative's on the top or bottom. And then cotangent is going to be -4 over 3, which is the opposite here. So that's example 1. Using your point, finding your r, getting your 6 trig functions. Okay, so let's talk about example 2, which deals with our unit circle. So our unit circle is basically just saying a very straightforward, easy way of giving you measurements for your circle. So you have y, you have x, you're given your circle. This is going to be your terminal angle. And in all of these cases, r equals 1. So your radius in your unit circle, because it's your most basic, r is going to be equal 1. That is a super important fact. So then all of these points wind up getting coordinates. So your x, think of it like your x-intercept is 1, 0, because there's nothing on the y. Here would be the opposite, 0, 1, because it's your y-intercept. On this side, it's the same as your x, but negative. So negative 1, 0. And down here, it's the opposite, but just negative 0, negative 1. So for your unit circle, most basic, the number 1 is used a lot. Your sine of theta here is still y over r, but because r is always 1 in a unit circle, y over 1 just equals 1. So your sine of theta in a unit circle is always y, and your cosine of theta, x over r, when r always equals 1, is just x. So it says a quadrantal angle lies in standard position whose terminal sides lie on the axis. So basically that's saying like these quadrant angles are each of the 4 quadrants. So they're always a 90-degree multiple. So we did this in 9.2. That would be 0, 90, 180, 270, 360. So the first one we're going to do is finding the 6 trig functions of theta equaling 270. So I'm a visual person, much like most of you. Let's draw out our angles. So again, we know that from 9.2, that's 0, and they all go up by 90. 90 degrees, 180 degrees, 270 degrees. So our angle that we're kind of working with looks like that. So, and it's theta. So let's add in now our new information about our unit circle. So we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And we're going to use that information to find our 6 trig functions. So x equals 0, y equals negative 1, and r always equals 1. So all 3 of these things will help us out today. So our sine of theta is going to be our negative 1 over positive 1, which is equal to negative 1. And our cosine of theta is our x over r. So that would be 0 over 1. And remember, anytime 0 is in the numerator, it equals 0. Tangent is going to be y over x, so negative 1 over 0. When 0 is in the denominator, remember we talked about how x can't be equal to 0. You get undefined. Cosecant is just the opposite, so 1 over negative 1, which is negative 1. Secant winds up being 1 over 0, so it's undefined again. And cotangent is going to be 0 over negative 1 or 0. So that is your example 2. I will be teaching examples 3 and 4 tomorrow. Thanks.